All right, so this is really my last section for the lecture this year, promise you. And we will spend this section to talk briefly about other alternative models which you could use for sensor data depending on the circumstances, the context, and the nature of the data, and so on. So this section is actually very newly added to the material this year. In earlier years, we didn't have that. However, we're aware that there are a wide range of models for the limited dependent variables type of data now, and therefore it probably would be helpful to have a brief overview so that later when you need something that fit to the problem at hand, then you have more choices. However, we would not be able to go very detailed about this model because you could actually spend a week or two just to learning about models for limited dependent variables. Therefore, we would not have time to cover that much, but hopefully that will be helpful. So now the first thing I want to stress before we go is that there's actually no universal way of classifying or naming these models. So that means for different textbook, different authors, you've seen many way of approach and classifying the model. So it's not possible to reconcile these approaches in order to arrive in a unified, systematic way um, of um, of classifying this model, right? But here I try my best to find the most suitable approach among the literature, and um, you're welcome to contribute to that or to give me feedback when you know something interesting out there about that. Okay, let's go. Now you remember in the beginning, in the introduction of topic one model, I already briefly said about different reasons for zeros. Now, so here let's set it at the start again. So we have seen topic one is a specific model for corner solution. What does that mean? Means that a person, for example, would in general would smoke, would participate in smoking. However, at the time you interview him, because of budget constraint or because the price too high, get too expensive, it's not affordable to him for him to smoke. Therefore, he, well, technically could also be a she, right, will deliberately decide to consume zero tobacco. So this, in this case, for the corner solution, it's called the true or the genuine zero. Okay, so meaning that's a decision to take, and it's really a zero consumption. However, there are other cases, for example, abstention. What does that mean? So that person would never smoke no matter what. If it gets cheaper, he would not smoke. Or you could go back to my example about my beer allergy. I will never drink beer no matter what. If beer is even cheaper, if I could afford a lot of it without giving up other things, I would still not drink beer, right? So that is the idea of abstention. So for example, if you come to me or you come to that person that never smoked, then that person or me or I will respond not applicable, something like that, NA. No. And then the person who take the survey or the person who enter this survey into the dataset may be coded yi equals zero in some way, right? Because numerical data cannot process this NA. So one way is to put zero. So that is just one example how um, another type of zero could enter the data over there. Now, so it's not a true zero, it's just unobserved, not observed at all, or data missing over there. And the missing data, NA, also can occur if the survey period is just too short, especially if you ask about durable good consumption, a car. You go to ask someone, have you recently bought a car? And recently maybe means the last 3 months. No? So a cars usually you only buy it once in several years. No? So in that case, a zero is not necessarily a zero because the person decided to consume no car, but just because it's not observed in that period. No? So the data could be missing or not applicable, like I said. By the way, this slide was based on the slide of Professor Stefan Hisch from TU München, and he's actually one of the lecturers for the Advanced Applied Econometric course for our PhD program. And like I said, you could spend a week with Professor Heckman and him only on limited dependent variable. Now, so this slide is taken from his slide deck for that. And in turns, we also have a very nice article from Humphrey and a textbook from Jones. Those are the source that we use to give you this overview. I will also upload the Humphreys on the campus for your reference later. Okay. So depends on why the zero are there in your data set, we could have different models. Let's start first with two models that we have been through, the TOBIT 1 and the TOBIT 2. So TOBIT 1 obviously was one for a real choice of zero consumption. We have seen that from the utility maximization motivation example already, right? So there's a particularly for corner solution zero. However, remember that we have one restriction with the TOBIT, that we have the same variables to determine both the probability of participation and the intensity. And this is one limitation for TOBIT 1, which we will see can be overcome by other types of model in the slide after. On the other hand, the sample selection model, also called Heckman or TOBIT 2 that we recently talked about, actually represents missing or non-response zero data. And for that, we can't really know when we look at why I equals zero, whether it's really because the person decided to consume nothing, zero, or because the data is missing and not applicable. So this is the category where TOBIT 2 model fits in. I will talk about it later a bit more with the missing and non-response and why is it the case with the TOBIT 2. Okay, so we have seen that TOBIT 1 model is suitable for corner solution zeros, but quite restrictive. So there are other models which are more relaxing in the assumption, and these models usually called the Hartle models. So Hartle models are very generic terms, and it includes many other models inside, but let's go with this generic term first. So first of all, it's applicable when yi equals zero is a true zero. So the corner solution here. However, it's different from the TOBIT model, TOBIT 1 model, that it has participation decision and consumption decision. So the two decision, the two process meaning we have two latent variables. So in this sense, it's pretty similar to the Tobit 2 model. And why they are different, I will come back later. Now, so in this category of Hadron models, we have two other subcategories. So the first one is applicable when the two decisions are made simultaneously and the error terms are correlated. Now, so again, that reminds you of the Heckman or the Topic 2 models, but still they're different. We will see now. And the candidate for this type of models is called full double huddle models. And that is the candidate for an appropriate treatment of the data. Now, if we assume there are no correlation between the two error terms of the two latent variables, and the decisions not made simultaneously, but rather sequentially, then we have two other suitable models, including the two-part models and the Cragg models. So the name after the author who proposed this type of model. Now, we will see a bit closer in the next slide. Okay, even though from the first look, the double huddle and the Heckman models are pretty similar, no? So they have two decisions, two latent variables, and the error terms from these two latent equations correlate. So in that sense, they are similar, however, still different. So let's see, start first with the double huddle models. Why are they called double huddle? Because two hurdles or two barriers have to be passed before a positive value in a dependent variable is observed. What are these two hurdles? The first one is abstention. So first of all, the individual must decide to participate or to smoke or to consume such thing and so on. So the first hurdle is the decision, the deliberate decision to participate. And what next? However, even one, for example, decide to smoke, he or she will not smoke if the price is too high. So that's the second hurdle, the corner solution. So in summary, for the double huddle model, we assume that the positive expenditure is observed if there is no abstention. But once the decision to consume is made, still there can be zero observation over there due to the corner solution. And this is transformed into a likelihood function with this form. Here, I rather use the likelihood function and not the likelihood function, so it's easier for us to see now. So the two hurdles capture in these observation with positive expenditure now, I small I in the set I1 for those that actually have positive observation of expenditure. Then the first hurdle hi equal to 1, meaning there's participation. Okay, but then it must also be that the yi is larger than 0 once there are participation. And the reason why there's this probability, that also means that there is a probability that yi equals 0 even when hi equal 1, right? So I decide to smoke, but okay, now price too high, my income's too low, I don't smoke now. But if I earn a bit more in the future, or price lower, then I will smoke, and then yi will be larger than 0. Now, so there is a probability for both cases. Now, and this again is the density that we have seen in the case of Tobit 2 model. But now conditional on both hi equal to 1 and yi larger than 0. Okay. And for the set of 0 observation over there, two things also. Because this is the probability of a positive expenditure, including two parts. Then 1 minus this part, probability will become the probability of observing the 0 over there. So it's actually the same, but just counterpart in the second term in there. Now let's again look at the likelihood function of the Heckman or Tobit 2 model. I jump ahead a bit and then go back to the text. Okay. Now, so we have the probability of hi equal 1, and then the density, conditional density, which is more or less the same there. But what is missing is we don't have this part. Let me highlight it. We don't have this part. This is not highlighting. We don't have this part down there, right? Why? Do you know why? Because of the assumption that once we have an individual deciding to participate or to consume something, then the consumption is definitely larger than 0. There are no possibility of observing a corner solution over there. So in this case, actually P, I have to change the color again, P the probability that observing yi larger than 0, conditional on hi equal to 1 from above, always equal 1. So every person who has decided to be a smoker will smoke something, will consume a non-zero amount of cigarettes or tobacco. And this is why the likelihood function of the Tobit 2 models reduced to quite simple case that we have seen. Actually, here earlier we know that it's actually P of hi equal 1. Sorry, equal 0. But just to make it compatible to above, I put it that way. All right. So you see that that's the key difference between the double Hutto and the Heckman models. So the core is actually with the Heckman models, there's no way to distinguish the corner solution from the non-applicable or missing values. Therefore, we assume that everyone has decided to consume or to participate will have a positive outcome, yi over there. Okay. The next thing we should distinguish is the difference between the double Hutto models versus the Cragg models. And for this purpose, we should write the likelihood functions a bit more explicit with x, betas, and the sigmas, the pros, the correlation coefficient of the two error in there. Why? Because, as I mentioned in the earlier slide, double Hutto model assume that the correlation between the two error terms of the two latent variables different from 0. So they are correlated just as the Tobit 2 model. And if we denote the pro as the correlation coefficient between the two error terms, and it will appear as some part or not, if not all parts of the likelihood function in there. Yeah. And the Cragg model basically used this general form of likelihood function, but then assume or applied for the case where the two error terms are uncorrelated. Hmm? So for the case that the unobserved hetero, heterogeneity of the participation has nothing to do with the unobserved heterogeneity that determined the level or the intensity. Okay, so for that, they will set rho equal to 0, and it's down to this type of likelihood function. And now if you set the limit, you take the limit of x prime s2I prime beta 2 over here and over here to infinity, it will reduce again to the Tobit 1 model, meaning the same set of explanatory variables explain both participation and intensity. Yeah? So that's just very general information, no need to go deeper in there, don't worry. The last type of model that I would like to introduce to you is called a two-part model. Was actually not new to you. I think earlier we talked about that already. And it, again, a model to apply for the situation where you have true zero, so corner solution. And it's similar to the Cragg model in the sense that the decisions are sequential and independent. So meaning there's no correlation between the error terms of the two latent variables. So in this case, we could apply a procedure similar to the Heckman or the Tobit 2 model, similar in the way that, okay, first we estimate the Tobit model to explain the probability of joining or not joining, consuming or not consuming, participating or not participating. So that's the Probit model. And then second part, OLS. Remember with the Heckman two-step procedure for Tobit 2, we also have OLS in the second part if we want, right? And just a linear model. But there we include the inverse Mills ratio in order to control for the extent or the degree of truncation of the distribution. And here we don't have that. So for the second step, you don't include without what's that, lambda in there. Why? Because we assume that there's no correlation. So this sigma 1, 2 is 0. So there's no such a thing in the two parts model, which makes it rather simple, straightforward, intuitive, and could be helpful in some cases. Of course, provided that your assumption about the uncorrelated error terms of the two latent variables are valid. Okay, so that is for the overview of alternative models for central data, especially the Hadron models for corner solution. So in general, I hope the lecture was helpful for you, and wish you a lot of success in the next year of your master program, but also later on with your career path if you ever applied econometrics there. It's been a great pleasure to accompany you in this course, and hope to see you in the next year in other classes or other contexts. Bye-bye.